Good morning, friends. At this time, we are talking about Spark with Python, developing Spark-based applications using Python. And if you go to the documentation, um, Spark programming guide is the one which you will have access at the time of certification if any one of you are planning to give the certification. And as I have been explaining earlier, you can scroll down or in the index itself there is transformations and actions. You can click on this and go to transformations and actions directly. We started with simple programs to read and write from HDFS. Then we have seen what is map, what is flat map, and a few more actions such as reduce by key, hands-on, group by key theoretically, and aggregate by key theoretically. And then we have seen few actions as well. Okay, so we'll continue on the same thing, on the same use case where we want to get average revenue. Okay, so last time what we have done is we joined orders and order items table and got total revenue per day, and then we also got total number of orders per day, and then finally we have divided the total revenue. Again we joined the two data sets, one with order date as key and total revenue as value, and the other data set with order date as key and total number of unique orders for that day as value. And then we joined those two data sets, and finally we got the average revenue. That is one way of doing it. Another way is while computing total revenue itself, if we can compute the total number of orders as well, then you don't need to join twice. So in that scenario, we aggregate by key will come handy. So I will not be executing each and every code snippet like the way I have done earlier. I will just explain how it can be done using my GitHub code, which is also copied into my website. Okay, so this is the example which will use aggregate by key. 1 minute. Yeah, aggregate by key to compute both the total revenue as well as unique number of orders. So I'm zooming in a little bit because the font is very light here. So now it might be better for you, but no, let me zoom out a little bit. Yeah, this should be better. Okay, so as we have done earlier, we have joined orders. Sorry, we have read orders and order items from HDFS. Then we have got order ID as key from both orders and order items dataset here, and then we have joined both the datasets, and then we have yeah, from here it will be a little bit different. If we want to do it, if you want to compute total revenue as well as uh, the total number of orders for each day at the same time without joining twice, from here the logic will be a little bit different. If you look here, as part of the map function, we are emitting a tuple. Okay, it's better I will run these things. Okay, I will directly copy and copy paste and start running these things. So I'm joining, I'm actually connecting to the lab. Okay, today I'm connecting from hotel. So if anyone is struggling to listen to my voice or to see my screen, immediately let me know. Don't wait till the last minute. Okay, and also as I'm talking from my hotel where I am getting only 2 Mbps, uploading the video will take some time. Probably over the weekend it will be ready. If you are expecting the video immediately, it might not be possible, but you can actually get whatever I'm discussing today from my website. If you go to the course Cloudera, sorry, CCS Spark and Hadoop developer, and go to this topic, transform stage store using Spark with Python. You will be able to see this, and you can follow this also till the time I upload the video over the weekend. Okay, so I cannot copy paste directly because there is no /user/cloudera in the lab, so I have to replace that with my user ID training 8634. So till here it is same as earlier, there is no difference. I have to start Pyspark. Okay, now now the join is working. Let's validate before we proceed further. So for in orders join order items take of 10 print of I. So it looks good, so we can proceed further now. So from this data set, what we are trying to do here is we are actually getting order date. So this one will extract order date. If you see, it's T of 1 of 1. So T is the parameter and T of 1 of 1 is this one. Okay. And then I am splitting it by comma, and I am getting the second value using the subscript of 1. So here I am getting, after splitting by comma, which will give the array. From the array I am reading the second element using 1, because the identification of array element starts with 0. 1 means the second one, which is date. And then the key is this one, not just date. It includes date as well as order ID. Order ID is nothing but this one. T of 0 is order ID. Okay, and then I am getting the revenue as value. So here we are getting date and order ID as key, which is a tuple, and then order revenue for each order item, or order item subtotal for each order item as value. Okay, now using this, if we want to use reduce by key, you will not be able to get the total revenue as well as the total number of orders in one shot. There might be a way, but it will be complicated. So here again we have to evaluate which aggregate function we should use. We have three options: group by key, reduce by key, and aggregate by key. So it's an aggregate transformation. For aggregate transformations, most likely we should not use group by key. There are exceptions to that. One of the exception is if the output volume after the aggregation is almost equal to the input volume, then group by key might be a better alternative. Even though reduce by key and aggregate by key works, it uses combiner, and combiner has little bit of overhead, and it can be slower if input volume and the output volume are the number of records which will be passed as input to the aggregate function, and the number of records which will come as output from the aggregate function. If the two numbers are almost same, then better to use group by key rather than the functions such as reduce by key or aggregate by key, which are just aggregate functions. Okay, so that is the exception when you should use group by key, even while you are performing simple aggregations like sum, average, etc. Okay, that being said, in this case, for each day we have almost 400-500 records or 400-500 orders, but when we actually get the revenue, it is one record at per date. So it is almost like less than 1%. In this case, you should use only the functions which uses combiners, such as reduce by key or aggregate by key. Now reduce by key and aggregate by key, we have to choose one of them. So the first criteria is whether input type for the aggregate function and output type for the aggregate function are same. if they are same, you can consider reduce by key. If they are different, then you cannot consider reduce by key. And let's explore that. So in this case, the input value type for reduce by key function is of type float. It's a single value which is revenue, which is being passed as input for the aggregate function. And output value type, after applying the aggregate function, is a tuple, not just single value. The tuple includes the total revenue as well as the total number of unique orders. So in that scenario, you should use aggregate by key. But here, before doing the final aggregation, using order date and order ID as key, I want to compute the revenue for each order. Okay, so order ID is unique for each day. Once the order is placed, the date will be same. Order date will not be different for two items in the same order, right? So using this as key, if we compute the revenue, if we compute the total revenue, that means you are getting revenue at the order level. Okay, so that's what we are doing first. We are using the reduce by key function here, and we try to get the order revenue. So let me execute these things and then you will understand. Okay, so first I am running this one, and now if I say for I in order join order items map take of 10, okay, print of I, and hit enter, you can see the key contains date as well as order ID. And then for each order item, you are getting date and order ID, and then you are getting the order item subtotal. So this is for one record from order items, we are getting the revenue. Now if you see, this 35,236 is repeated 5 times, which means that this order ID might have 5 or more order items, because we are only seeing 10 records. There could be more order items also somewhere in the data set. Okay, so first what we are trying to do is we are trying to compute order revenue for the order ID. Okay, so within the date, the order, all the items for the order will be repeated under the same day. So by using this key, we can safely, 1 minute, okay, by using this as key, we can safely compute revenue at order level. So that's what we are doing first here. So let me run this. In this case, to compute the revenue, we can use reduce by key, because the input type and output type, input value type and output value type is float. Input value type is input value is nothing but revenue for each order item, and output value is nothing but revenue for each order. Okay, so the data types are same, so we can use reduce by key directly. So here we are just using reduce by key function. Okay, then if you print for I in revenue per day per order take off 10, print of I, and hit enter, you can see now the order ID is not being repeated. Every time it is unique, and it is adding up all the subtotals, and it is giving the final revenue for each order. Now we don't need order ID as part of the key, so we'll discard order ID, and this map function is actually discarding the order ID. It's simple transformation for each record where we have order date and order ID as key and order revenue for that order ID as value. We are just discarding the order ID. Okay, so here if I say for I in revenue per day per order map take off 10, print of I, and you can see order ID is discarded. Now using this, we have to apply the transformation to get the order revenue for each date, and also total number of unique orders for each date. Okay, now we cannot use reduce by key because the input value type is just float, whereas the output value type is a tuple which contains the revenue for each date and also the total number of orders for each date. So for that reason we cannot use reduce by key. We can either use combine by key or aggregate by key. Combine by key is not that important. It is strikingly similar to aggregate by key, and I will not be covering combine by key here. Instead I will go with aggregate by key and I will explain how to develop aggregate by key. Okay, it is very important. You have to be completely attentive because this is the most confusing transformation people are complaining about. So be sure you are very attentive when you are trying to use aggregate by key, and it is very important transformation. Okay. So in Mohan is asking, in reduce by key, when we have multiple metrics to be aggregated, will it automatically do? When you say multiple metrics, what is that? We will come back to that a little bit later. You have to be a little bit more specific for this question, but let me finish the aggregate by key and then we will come back to this question. Okay. So if you see, the aggregate by key function takes 3 parameters. Okay, and let's go to the documentation first. And this representation is primarily for Scala. If you want to change it, just go to any section, and wherever there is Scala, Java and Python, if you choose Python, automatically the syntaxes will change for Python. So it's very easy to switch between the documentation for Scala, Java and Python as part of the Spark documentation. If you click on this, all the examples will be shown with Scala syntax and semantics, and if you click on this, all the examples will be shown in the Python syntax and semantics. Okay, now I have chosen Python there, and if you see, so here they haven't changed. They should have changed this table also when they did that, because when you implement with Scala, you will call it like this. So this is where you will initialize, and then this is where you will actually write combiner logic and reducer logic. Okay, whereas in Python, all these three will be 3 different parameters within one circular brackets, whereas in Scala there are 2 circular brackets. You will understand when we talk about Scala more, but for Python there won't be one circular bracket for initialization and one circular bracket to implement the combiner and reducer logic. Okay, so if you go here, if you go to the code snippet, here you can see where is the aggregate by key. Yeah, this is the one. If you see the code snippet, so the circular bracket for aggregate by key starts here and it ends here, and the first parameter you will say what is the output value type, and you have to initialize. As these are not strongly typed, you can just say, you can initialize and say the data type of tuple by in one shot. You can directly say like this. So the first parameter is the output value initialization. By providing the values, you will be hinting about the data types also. Okay, so the first parameter is telling the output value type is nothing but a tuple, and they are of numeric types. That's what this first 0, 0 means. And then comes the lambda functions. The first one is for combiner logic or sequence op in Spark terms, but in conventional MapReduce terms, this is combiner logic and this is reducer logic. As per Spark documentation, this is sequence op, this is combiner op. Okay, I don't know why they have changed it. It's all kind of politics between different technologies. They don't just want to follow the other ones. Okay, so here both of them are taking 2 parameters. One is let's talk about the first one. So the first one have accumulator and the revenue. So accumulator is whatever we have initialized. So accumulator is of type tuple here, whereas revenue is whatever is the input. uh, to this function is the second parameter. So what is the second parameter? It's just a float value, a single value. So it's a plain simple float value. So you cannot subscript when you try to use this one in this case, because it's just a single value, it's not tuple. Whereas this one is an accumulator, means whereas this one is of type tuple, because we are initializing it as tuple here, and this has to match the output value type. So it has to be tuple as for the initialization. Accumulator also will be a tuple, but it's an implicit, it is managed implicitly. Okay, and here in the tuple I want to store the revenue as part of the first parameter, and the total number of orders as part of the second parameter. Okay, so I am adding revenue for the first attribute to the tuple in the tuple, and I am adding just one to the second attribute in the tuple. Already we are getting one record for each order for each in each date, and as part of the output for the last reduced by key and map function. Hence we can use this information, and for each date, if we just add the number of records, you will get the number of unique orders for that day, and if you add the value, you will get the total revenue per day. That's what we are doing here. We are performing count by saying this, which will get us the intermediate values for our number of records for each day, and here we are actually adding the revenue. But this is not the final output, this is the combiner output. Now we have to use this information and add these intermediate values when it goes to the reducer side, and then get the final values. So in this case, both the parameters for the second anonymous function or lambda function are of type tuples. Okay, so here we are just adding first values of tuples which are nothing but intermediate revenue for each day, intermediate sum of revenues for each day, and the second one we are just adding the intermediate number of records within each day, and then the output of this will be the total revenue for each day and total number of orders for each day. Okay, this is how you have to develop the aggregate by key function. First parameter will be the initialization of the output value, and then the second parameter is sequence of or combiner logic. Third parameter is combiner op or reducer logic. So as I have explained as part of combiner theory last week, combiner will only compute intermediate values, and finally we have to add those intermediate values to get the final values. That's what we are doing as part of this, and both total 1 and total 2 are of type tuples, and we are just subscripting to get the revenue for both the tuples. That's why we are saying total 1 of 0 plus total 2 of 0, and round is the Python function where we want to round it to two decimals. Similarly, we are adding totals here. It's of type integer, just adding is enough. Okay, now I will run this one, and then I will also run this one. Now you can see that for each day we got the revenue and total number of orders in the form of a value, and that is nothing but tuple. Okay, and then let us perform the count to validate how many records it is getting. For that you can just say dot count and hit enter. It's 364 records. Okay, and then finally, to get the average revenue, you just have to apply the map function. The date is the key here, and then we are just I saw that question. Give me a few minutes. Let me finish this off, and then I will come back to the question. Okay, so here you can see we just have to extract this one and divide it with this one to get the average revenue for each day, and that's what we are doing here. Okay, and then you can see the final result like this. So for each day we are getting the average revenue. If you want, you can again use the round function and round it off. I have explained as part of the last class. It will be better to go through that. You need to understand the combiner logic to understand that what is the relevance of the combiner and all those things. I cannot go back again because already we are way too way too back. And if you want to go through that, if you go here, if you go to my website, there is a video on the combiner itself. So if you look at this, combiner will actually generate the intermediate values, and once you get the intermediate values as part of the reducer, you have to add those intermediate values to get the final output. Okay, so go through this video, it will be clear. If you still have questions, then we will see as part of the Q&A in the next class. Okay, so now Mohan, what is your question on reduce by key? I could not understand that. If you can rephrase that question, it will be better. Okay, that's fine. So so this is how you have to write aggregate by key functions. Get few more use cases and start implementing those things. Then only it will be clearer to you. I have taken the simplest use case so that you guys can understand. Okay, and also if you want to know how to get min and max, I think I have. So let me check. Yeah, so another very good use case for aggregations using the transformations such as reduce by key or aggregate by key is getting max revenue or min revenue, etc. Max and min also considered as aggregate functions, and here the use case is, the problem statement is get customer ID with max revenue for each day. Okay, so within each day I want to get the customer ID who is generating the max revenue. Okay, so from here to here it is same, we are just joining the data set. Okay, I'm pasting it here and replacing with training 8634. Okay, so now after that what we are trying to get is, we are trying to get the date and customer ID, because we want to get the customer who is generating the maximum revenue. Let me check whether what we are getting. Let me for I in order join order items dot take of 10 print of I and hit enter. So from this we are trying to get date as key, and then and then customer ID as another key. So customer ID is this one, this 3987 is the customer ID. Okay, once you have date and customer ID as key and revenue as value, for each customer you will be able to compute the revenue, and that's what we are trying to do here. We are just using reduce by key. In this case it's simple addition of revenues to get the final revenue. So the input value type and output value type are same, and the function is the additive function. So the combiner logic and reducer logic are also same. So we don't need to use the aggregate by key function here. Okay, so we can directly run these two code snippets. The first one gave us the date and customer ID as key and revenue order item subtotal for each order item as value, and we just have to add all the order item subtotals holding the key, and that's what we have done here. And if we see for I in revenue per day per customer dot take of 10 print of I and hit enter, you can see this is customer ID, this is date, and this is the revenue for each customer. Now for each date I want to find who is the customer buying most number of products. Okay, so in this case it's we are trying to min and max, so we have to apply this logic of comparison here, and this is the syntax of how you compare using Python. Okay, so what it is saying is if x1 of greater than I will come back to from reduce by key point of view in a moment. What we are trying to do is if x of 1 greater than or equal to y of 1, okay, then x, so we are returning x, and else y. So there is a question from Pramod, since there might be a performance issue by using reduce by key versus aggregate by key, there will be no performance difference between reduce by key versus aggregate by key. Both uses combiner. Even if there is any, it will be very negligible, and it doesn't matter which one you use as part of the certification, as long as so you can implement a reduce by key functionality using aggregate by key, but there are some functionalities which can be implemented using only aggregate by key. In that case you cannot use reduce by key. Okay, so that's you have to keep in mind. If you want to use only aggregate by key for all the aggregations, that is fine, well and good. Reduce by key reduce by key simplifies the implementation where you don't need to customize the combiner logic. Okay, anyway, and now coming back to this, let me execute this one also. In this, what we are trying to do is, and then I will come back to the reduce by key function to compute the maximum revenue generating customer. So in this, what we are trying to do is we are moving the customer ID, which is part of the key, to value, because after the revenue is generated, we don't need this part of the key. It should be part of the value, so that we can identify who is the maximum generating customer. Okay, so for that reason we are moving this customer ID, which is the second element in the tuple of which is representing the key, into the value. So if you look into the output of this map function, dot take of 10 print of I, and hit enter, now you can see that the key has only date and the value have the customer ID as well as the revenue for that customer for a given day. Okay, so now we can use this this one, because here we are, as part of the reduce by key, we are in lambda function we are passing two parameters. One is accumulator and the second one is the revenue itself, the value itself, and the value is of type tuple. So if you want to compare the revenue, we have to subscript to extract the revenue. So in this case, using this if function, we are comparing the records based on the revenue. And if x of 1 means if the value which is in accumulator is greater than or equal to the incoming value, then we are preserving the accumulator. Otherwise, we are assigning the incoming value to the accumulator. Okay, so this function will return will reset the accumulator if the incoming value is greater than the existing accumulator value. So accumulator will be reset after every iteration whenever the incoming value is greater than the accumulator. At the beginning, the accumulator will be initialized to 0. So anything that is coming as part of the input value to the aggregate function will be greater than the accumulator. Then accumulator will be reset to that first value, and after that, if the second value is greater than first value, second value will replace the accumulator, Otherwise, accumulator will preserve the first value itself. Like that, it will try to preserve the maximum value until the last iteration, and then for each key you will get the maximum, you will get the record which have the customer ID and the maximum value, which will be the output of this reduce by key function. So this is how you can apply min and max as well. If you are not very comfortable writing this code snippet as part of the lambda function, you can also define Python regular function, and you can invoke the Python function like this. Okay, so I will use this manner here. So we have defined a function called find of max, and here again we are not telling what is the data type of these parameters. It is implicitly determined. Python is a loosely typed language. You don't specify data type anywhere, but based on the function invoked, it will inherit the type whatever parameters you have passed. So if you pass a tuple here, it will be considered as a tuple. If you pass an array, it will be considered as an array. So it all depends upon on which we are trying to invoke this function. In our case, we are trying to invoke this function on the tuples which are being passed after the last reduce by key logic. Okay, sorry, not reduce by key logic, map logic, which is nothing but a tuple. So here I am running this one to get the max revenue. And here we can say for in top customer per day by revenue, take off, or we can even do the collect print of I and hit enter. Now you got the customer ID who have the highest revenue, who are generating the highest revenue per day. Okay, another good insight if you want to explore further as an exercise is what is the day on which a customer has spent the most amount of money. If there are multiple orders for a given customer on multiple days, if you want to get on which date or on which category of products he is spending more money, those are very good insights which you can explore using this data model. For the latter case, where in which category the customer is spending more money, you have to join multiple tables. You have to join orders, order items, products, and categories, and it will be a very, very good exercise for you to understand the concepts behind this. For certification, it is not required, but to understand how to build the applications using these transformations and actions, that will be very, very good exercise. You have to implement many transformations using programming language of your choice. Okay, so that being said, that's it about the aggregations, by key aggregations, which is very, very important topic. And this is especially as a data engineer, this is a quite common scenario where you have to perform the aggregations, joins, etc. So in this we have clubbed both joins and aggregations together, and we have performed the hands-on stuff. Okay, so now I'll go to the next topic. Let me zoom out a little bit. So the next topic is filtering. It's a very simple thing. So I will not run much of the programs here. You just need to understand there is a transformation called filter if you want to discard some of the data as part of your processing. So there is a question from Mohan. How to join when we have multiple columns as part of key? Also, sometimes in key, while joining, we have to join 3 columns for one dataset and 4 columns for another dataset. I did not get the second part. It's pretty simple. If you have to join, so there are certain prerequisites while performing the join. Okay, the prerequisites are the key has to be same. Okay, it need not be a single attribute key. It can be a tuple also. So the key can be a tuple. So as part of the tuple, you can generate all the 3 columns if you want to join on 3 columns from both the data sets, as long as the type of the key for both the data sets are same, you can apply join and it will give you the results. Okay, but I could not get the second portion of your question, but for your first question it's simple. You have to make sure that you already extracted in proper order for both the data sets you want to join, and also the data type of key of both the data sets have to be same. Then only you will be able to apply the join transformation to join the data sets. Yeah, does that answer your question? Okay. So now the filter is a very simple transformation. If you just want to discard or filter out the records which you are not interested, then you can apply the filter logic. For example, if you just want to get completed all the orders which are in completed state, so just read the orders data, create an RDD for orders, and then apply filter, and as part of the filter you can actually invoke the lambda function and you can apply the logic on which you want to filter. Here we are saying in the orders, the last field is order status, and there are 4 fields in orders table. First one is order ID, second one is order date, third one is order customer ID, fourth one is order status. So to extract order status, we just have to split because the data is separated, comma separated, we are splitting by comma, and then we are using subscript of 3, which is nothing but 4th field in each of the record, and we are comparing with complete. Okay, so only the completed records will be printed. So here let me directly copy paste this one. Already we have orders RDD, so it will work. You can see that we are getting only the completed records, completed orders. Similarly, if you want to compare using similar to like in RDBMS, you have to do this. So pending in, so if you go to this data set for I in orders RDD, take off 100, print of I. Gopi have asked a question, but I forgot to, I overlooked that. Let me go back a little bit and read that question before we do this. So I lost connection in between. I saw that combiner, but combiner is nothing but applying reducer logic at each data, right? Yes, that is right. Then the final output will be cascading them. I'm not sure what cascading means here. Yeah, the final output is adding those intermediate values which are generated by combiner. So reducer function will always add that combiner output. That is what I wanted to ask. That is correct. Reducer function will always add or whatever functionality you want to perform on those intermediate results. So in this case it's adding. In other cases it could be different. Typically it will be the same. Whatever type of functionality you are applying on the combiner, you will be doing the same on the reducer. Okay, so now coming back to the filtering, sorry for the delay, Gopi. So I hope that is clear. If not, we can discuss offline. So here unless others also have some concerns about reduce by key and aggregate by key, we will defer the discussion for now. So here if you see, when it comes to pending, there is there are orders with pending payment, there are orders with pending. So I want to get all the orders which are either in pending payment or pending, or if there are some other pending statuses, I want to get all those things. Okay, so that for that we can just say like this. This is again the syntax of Python which we are trying to implement. Once you have array, once you have a value, if you want to compare similar to like operation in RDBMS, you have to say in this case. Okay, so I am copying here. And pasting it here. Now you can see, means the first few records are all pending payment. So let us take off 100. Let me, it's correct, then why it is failing? Yeah, take off 100. Okay, I got it. So I have to copy till here 100, print of I. I'll come back to your question, Mohan. So if you see here, if you try to look into 100 records, you can see it is getting both pending and pending payment. So in Python, if you want to implement similar to like operation, you have to use in, and whenever the pattern of whenever the string pattern is there in a given record, it will match and it will return that record. So that's what is happening here. So let me see the question of Mohan. Okay, so there are some questions on joins. So let's sort it out. You have order ID in master table, order ID, order detail ID in order detail level, order ID, order detail ID, order distribution ID in distribution level. I was asking how to join. So it's simple. First you have to join orders and order detail, which will and then you have to get the map function having order ID and order detail ID as key, and then you have to extract order ID and order detail ID from distribution level, and then you have to join those two things. So first map read orders, read order detail, and then apply the map function to get order ID in both the tables. Once you get order ID in both the tables, you will be able to join. And then if you want order detail ID as value, you can extract that as value. Okay, so order ID will be the key and order detail ID will be the value after joining the data sets and few other elements. And then if you want to join with order distribution table with order ID and order detail ID, then you have to apply map function again to move order detail ID or to have a copy of order detail ID as part of the key. After that map function, which will emit order ID and order detail ID as key, you have to use that one to join with the order distribution. So before joining with order distribution, you have to apply the map function on the order distribution data, extract order ID and order detail ID as key, and now both the data sets have the same you have RDDs with the same type of keys, and you can join those two RDDs without any issues. Okay, I hope it answered your question, Mohan. If you still have questions on that, I can explain. So yes, Pramod, join happens only on pair RDDs. That's correct. And how to build the pair RDDs is by using map function, and you have to get that key matching keys before joining the datasets. Pramod is following very well. I think he's practicing quite a lot. Yeah, he's actually responding to the questions. I'm very glad. So that's about filters. You need to understand different options. I have given many options here to apply the filter logic. So just follow that. It's very simple. Filter is the simplest transformation, and try to use filter to perform some advanced functionalities after filtering, like joining and aggregations, etc. At that time you will understand how to connect all these things and come up with the final applications. Okay, so I'm moving on to the next topic. So here the next topic is another very important thing: sorting and ranking. Okay, so when it comes to sorting and ranking, So there are again global sorting and by key sorting and ranking. Okay. So total ranking is very simple. There are actions such as top. If you use top, you will get top 5 records, and the values, the records will be sorted in descending order, and it will give you the results in descending order. So let me explain you a little bit here before going on to the next topic, which is by key sorting, because you need to understand how the data is represented when the data is being sorted. So in this case, sort by key, even though it is saying by key, it is kind of it is used for global sorting itself. So global sorting based on a key will be done if you do sort by key, and it's a transformation, it's not action. Whereas top of 5 and there are few other things which are actions. Top is Python function or Spark function. I think it's both. Means they might have overridden the Spark function, Python function as part of Spark, because if you go to the Spark programming guide, there is a top function even in Python. Okay, and the functionality might be a little bit different. They might have overridden as part of the Spark. You will see a lot of functions overlapping between the underlying programming language and Spark. Okay, so top, where is that? I think top is just a Python function. Yeah, top is Python function. It's not a Spark function. Okay, but there will be overlap sometimes. Where there is overlap, Spark will try to override the underlying programming language functionality. For example, in Scala, you have you have map, reduce, etc. in typical Scala itself. Okay, but when it comes to Spark, they override it. Even here, there might be some overriding internally for the same functions which are already available in the programming languages. Okay, now I'm clicking on actions here. So let us go back to this one, and already orders is red. So let me first apply the map function. Take off 10, print of I, and hit enter. Orders RDD. So here you can see that I am just getting order ID as key, and I am getting the record as value. Nothing fancy here. Okay, and after doing that, I am just applying the sort by key, and I am actually sorting the data on order ID, which is already there, so you don't need to much worry about it. If you want to sort by order status, you can extract it as key and apply it as apply sort by key on that, and the data will be sorted by order status. Okay. Okay, Pramod have mentioned that top is a Spark function. It is one of the functions on RDD. Okay, thank you, Pramod. You can actually respond to everyone. There is no need to send it to me privately. If I assume, I say I assumed. That's why I said I think last time. Okay, so that's fine. So if you want to sort in descending order, you just have to say sort by key false. False is again Python Boolean value. True and false are the Boolean values in Python, and we are passing that Python Boolean value false to sort by key to sort the data in descending order and get the data in descending order. And then top will actually work like this: sort by key by false with false, and then take off 5. Take off 5 will give you the first 5 records. So once you get the data sorted, to print the first 5 records, you just have to say take off 5. Top will work in the exactly same manner of applying sort by key with false and take off 5. Okay. So that's about, and then there is another very important function for global sorting, which is called as take ordered. Okay, for example, in this case, I want to, so let's take the example of another data set. Rather than orders, we will take the example of products, and I want to check what is the top priced product. Okay, so for that, first I need to read the, or we want to get the products in the descending order by price of the product. So for that, what I am trying to do is I am actually applying products RDD. I am creating products RDD here, and then I am reading the products data. Okay. Okay, so we have created a place for RDD for products, and using this, I just if I want to get the sample for in products RDD dot take of 10 print of I. You saw that there are multiple fields, and this is the product price, and so the product price field is 1, 2, 3, 4, and 5. So fifth field, on fifth field, if you want to sort the data, and if you want to get the entire record, not just the price but the entire record, you can use the advanced transformation function called, or it's an action, I think, action called take ordered. Okay, in case of take ordered, you can invoke the lambda function and say on what value you want to sort it. Okay, so in this case, if you want to get the fifth column, you just have to apply the split function, and it will give the array, and out of which you can extract the fifth column, and then you can automatically the data will be sorted based on that. And here I am only getting 5 records, that's why I am saying it as 5 here. So 5 represents how many records you want to get. If you want to get only top priced product, you can just say 1 here, and then it will give the actual record itself, rather than just giving the product price alone. So we can apply similar to this. Yes, as part of this logic, you can apply using multiple fields also. So take order gives you that flexibility. Whatever is valid as part of the lambda function, you can apply that, and based on that, it will try to sort. Okay. Sometimes you have to concatenate multiple columns because you might not be able to, or you can create it as a tuple, etc. You cannot just directly keep on adding those columns. You have to define a proper structure for that, on which you want to sort even with multiple columns. Probably tuple will work in most of the scenarios. So here I am trying to get the data from products RDD and split on comma, and the price is, this is 0, 1, from here to here 2, 3, and 4. So I have to give 4 here. It will fail because there is one bad record in the products table, due to which it will fail. But we can apply filter function and we can filter it out. See, it is failing. Okay, so let me filter it out. I have the information on my GitHub account. Yeah, actually what we can do is, in this itself, filter, okay, lambda x. So we are applying lambda function here, and we are, and also here it is not int, it is float. So the error is because of that, but there is one bad record also. So as part of the filter logic, I am saying if this one is empty, the is not equal to empty, then only I want to get. I think I have to give single quotes. Let me try. So I want to filter out the records where the product price is empty. Okay, and this might also fail. Let us see. Okay, here I have to say dot. Yeah, now it looks good. So we got it in ascending order. So we got all the 5 products with 0 as value. Okay, if you want to sort it in descending order, you just have to say minus here. Okay, so now you can copy, paste this one and hit enter. Now you can see the top 5 priced products, and we are seeing the entire product record, not just the product price. That is because of the take ordered function. It is very handy function, very important, probably not from the certification point of view, but at the time of implementing the projects, this take ordered can give you a lot of flexibility, because you can get the entire records, entire result set by applying this transformation to sort the data in a particular order on one particular value or on combination of values within each record. Okay, but one caveat is take ordered is when you think about ranking, right, or ranking or sorting, there is both dense ranking as well as sparse ranking. Sparse ranking works well if so ranking works well, or sparse ranking will work very well when your data is almost unique. Means if all the products have different product price, then always top 5 products will have top 5 different prices. But if you want to get if you want to apply dense ranking, example for dense ranking is, instead of getting top 5 priced products, I want to get all the products which are having let me define this way. Let me think about the problem statement and I will get back to you. I always confuse a little bit over here. So get top n priced products. Okay, which means that top 5 priced products. When I say top 5 priced products, you might have more than 5 entries which have top 5 priced products. So in this case, if you see, the first price is 1999.99, then there are 3 which are 17.99, and then the 5th one is 10.99. So even though we are getting 5 products, there are only top 3 prices here. So when it comes to dense ranking, take ordered means transformations or actions such as take ordered will not work. Even the top will not work. We have to write our custom logic. Okay, so I have demonstrated as part of the next topic in the course, which is this one, sorting and ranking using Pyspark by key. So we are performing by key sorting and ranking here, and I will go to the code snippet directly and I will showcase how to achieve that. So the requirement is here not just globally, but with so let me define the problem statement first, then I will explain it here. Okay, so you have this data of products, and products have product category ID. So this is the product category ID. So holding the product category ID, for each product category ID, I want to get top 5 products. Okay, top 5 priced products, not just top 5 products, top 5 priced products or top 3 priced products. Okay, so in this case we will be using both group by key and also the sorting. This is where I will actually cover the group by key, how group by key will be used internally. Our group by key can be used to develop the Spark based applications. So for this, first you need to read the products table. So that's what is happening here. So this is the code snippet for products, and here the location is under user training 8634. Once the products is read to RDD, we are actually applying the map function and getting the product category ID, because we want to get the details within each product category. Okay, so this will take care of that logic. I am executing here also, and now okay, I have to give, why it is not working? Okay, I didn't copy this one. Okay, now products map for I in products map dot takeoff 10 print of I, and you can see it here. We got 10 records, and the key is the product category ID. It is very important, even though I am not casting here as part of the applications. If it is of type integer, you should cast it here itself. Okay, because integers are always better to manage than the strings. Because the input record is string, it is interpreting it as string, and it is always better to cast it when you apply the map function, and when you extract the keys which are of type integers, you should immediately cast it to integers. In this case I am not doing that, but you should follow that as a best practice. Okay, so now we got the product category ID, and within this product category ID I would like to get the top n priced products, and we cannot use reduce by key or aggregate by key because the logic is very complicated. Even though it's an aggregate function, it's a complicated logic. We have to sort the data, we have to then extract top few products to get the results. So we cannot directly use reduce by key or aggregate by key. Hence we have to explore group by key. So before writing the final code, let's understand how the data is represented when group by key is implemented. So I am copying this code snippet which applies group by key. Okay, and after applying the group by key, I just want to say print of I, so that we understand how data is represented. So in this case, on group by key you cannot actually read it, so you cannot actually print the data. So what we have to do is group by key take off 10 and then print of I. Okay, if you copy paste this one. So group by key, then transformation. On transformation you cannot actually print the data directly. You have to apply actions such as collect and take, then only you will be able to see the results. And now if you see, for each product category ID we are trying to it is returning a iterable result which is nothing but an array or items. So for each category ID it has already grouped. It is not showing up here because it is actually showing the object address rather than actually showing the results, but internally it will have all the records related to category ID 11, and this one will have all the products related to product category 24. So now you got all the elements for a with respect to key as part of one collection, and then you can apply Python based collection operations on this data set and then perform the transformations. So that's what we are trying to do here. So if you go back to my GitHub to my website, okay, so I am creating a function called getTopDenseN function, and it takes two parameters. One is the records which will be passed to which will be passed using the output of sorry, let me rephrase it this way. So here we are trying to pass the results which are output from the group by key to this get top densen function as one of the parameter, and the rank, how many n prices you want to see, is passed as the second parameter. So as part of this lambda function which is applied using flat map, I will explain why I am using flat map in a moment. Here you will get the number of records for each key. Okay, so in this so the rec will be collection, not just the individual values. What is the rec? So this will be the rec. For each iteration you will get it will pass this as the parameter value. Okay, so this one will, for each iteration, this one will represent the collection, and this one is the parameter which we are passing to get n number of records after each iteration. Okay, so I am initializing 4 arrays: x top n prices, prod prices, and prod prices descending. You will understand why I have used 4 here. So as part of the first iteration, so rec is nothing but a collection, and here and it's not just collection actually. Rec is the tuple. The tuple is nothing but both the key and value. So here I am passing both key and value. If you want, you can actually say rec, and also while invoking, if you want to write it in a different manner, you can also where is the flat? Yeah, here. So you can also actually say x of 1 directly here. That way you can only pass the second element of the tuple rather than passing the entire record. Okay, so group by key is nothing but a tuple. Group by key generates a tuple for which the key itself prod category ID and the value is the collection related to that prod category ID. So it depends upon what you are trying to pass. So here I am passing the entire record. The record is nothing but key value tuple. The key is prod category ID and the value is the collection. So here I am iterating through the collection. That's why I am saying rec of 1. Okay, and then I am actually getting only the prices for all the products. Okay, if you see here, I will represent each element of the product, each element of the product under a particular product category here. So the I itself is complete record of product, not just one element of that record. So I have to split that. So that's what I am trying to do. The fifth element is the product price. That's why I am splitting here, and I am casting it as float, and then I am actually appending to product prices. So this product prices is being built as part of this iteration. Once that is done, once the product prices is retrieved into a collection, I am applying this Python based collection functions to apply collection operations on this collection. Okay, so first what I am trying to do, I am converting this product prices into set, and then I am sorting the set, and then I am converting into a list, and when I am actually sorting, I am sorting in reverse order so that I can get all the product prices in the descending order. So what I am trying to do is, so there is a collection, so here I am creating a collection 1 2 3 4 6 0 5 8. Okay, and also I will have some duplicates 3. So that is list. I can say I, and it will print the list. So I want to get the set on this. Set is nothing but unique values. So now as part of the set, it has removed the duplicates. So we got 1 2 0 1 2 3 4 5 6 8. Okay, and then I am sorting the set of I in descending order. So reverse equal to true. Okay, now you can see that results are returned in descending order. Okay, and then I'm converting into a list so that I can apply few other operations downstream. So now I'm saying list of the this sorted output. So the same thing I am trying to do on the product prices. So the set after sorting I am converting into a list. Okay, so list have different APIs which can be applied, and sort have so set have different APIs. I want to use the list based APIs downstream. That's why I'm converting into a list. So now I want to get so earlier we have values like this which are having duplicates. We have applied the set operation to eliminate duplicates, then we have sorted the data and we have converted it to a list. Okay, now I want to get only top few products. Instead of getting everything from this result set, I want to get only top few products, whatever is top n here. So let's say you have applied top n here, then you can so there is a package called iter tools. You have to use this one. So what we are trying to do is import iter tools, and then I am actually saying list iter tools islice. Okay, and this one only takes list here, so we have to pass this list, and then we can pass how many records you want to get from the first element. So first element is represented with 0, that's why I'm passing it as 0 here, and then 3. So now islice is closed, and now the list is closed, and hit enter. So there is some issue with the syntax. So let me see what is the issue. I think there is one additional bracket somewhere. Yeah, so there is additional bracket here. Now we got only top 3 priced products. So we have applied Python based collection. So this emphasizes that you have to, means not for the certification. In certification they will not give this much complicated questions, but while developing the applications you need to be familiar with collection framework, whatever programming language you chose, whether it is Python or Scala or Java. You need to understand the collection framework so that you can simplify your application logic. So in this case we are using a collection package called iter tools, and we are trying to get top n products from the already sorted data. So all these things are nothing but collections only, means we are performing the collection based operations here. So top n prices will get top 3 prices or top 5 prices, whatever is passed as part of top n, and now we have to iterate through the data, and whatever record that falls under top n category, top n priced product, will be returned. So that's what we are trying to do here. We are trying to build a collection called X, which will have all the products with top n prices. So in this case, if we have 10 products with the top 3 prices, this X will have all those products. And finally we have to do this to loop through the final collection, which will have the top n priced products, and return as output. And then we have to apply flat map on that. That's why we are using flat map here. If you don't use flat map, it will not work. Flat map will flatten one record into multiple records. Here our input record for each iteration is a tuple which have a key of type product category ID and value of type array, whereas the output will be the individual records which matches our top n priced products. That's why we are using flat map here. Okay, so that being said, now you can execute this get top dense n function. That means we are creating in this session. Why these are all well tested? Why it is saying? Okay, I know why. It has to be indented. Okay, so I will fix this code later, but for now I will just use Sublime Text. Just indent it, and now okay, now the function is created. and we can invoke that function like this and hit enter. Okay, so there is one bad record which is saying could not convert string to float. So here I have to apply the filter logic before actually applying this flat map function, and then use the get top densen function as part of lambda function. So here, where is the filter? Yeah. So filter, take this one and use it here, and then we will apply the map function. Okay, now I will try to run this. I hope it will work, otherwise we will see. Yeah, now it is working. Now you can see we are trying to get how many top products? We are trying to get 2 top priced products, and you can see in each category, not just overall, but in each category. So for 34 category ID, the top two priced products are top 2 prices are 169 and 149, but there are almost 10 of them which fall into that category. So this is how you can implement the advanced aggregations by leveraging the APIs of the underlying programming language and integrate with the Spark based APIs to develop the full-blown applications. Okay, so that being said, we are done with Pyspark, and from the next class we will start talking on Scala. So it will be quick. We will try to wrap up in 2 classes. By this week, Spark will be done, and the key is practice, because there are too many things which you need to learn. You have to learn Scala programming language, you have to learn Python programming language to claim that you are employable in those skills. And then Spark is only part of it. Spark is probably 10% or 15% of overall implementation. The main aspect will be, especially for job, is to learn Python and Scala and start exploring these features of Python and Scala where they can be integrated with Spark based APIs to come up with final solution for your business requirements. So I will take few questions here and then we'll wrap up for today. So Pramod is asking, is it important to remember and distinguish between all methods which are transformations and actions? It is not important to remember, but you should be able to interpret when you go to the documentation. Documentation will be available even for the certification exam. So you have to know how to get the information from the documentation. As long as you can interpret, that is enough. You don't need to remember, unless some nutcases who only focus on syntax and semantics rather than the actual stuff. You hardly encounter the requirement of answering those questions.